Welcome to the Neuromodulation podcast, presented to you by the International Neuromodulation Society. Dive into the forefront of today's emerging neuromodulation techniques, insights, and ethical and clinical applications. Subscribe now to join the multidisciplinary collaboration of medical care providers, scientists, and engineers who are part of the global conversation that's shaping the future of healthcare.
Welcome to the INS podcast. Today we've got a wonderful opportunity to peek inside the mind of an extremely well-regarded and famous inventor. Therefore, it can be none other than my good friend, Professor Dirk De Ridder. Dirk, welcome along.
Thank you very much, Mark.
Right, our absolute pleasure. Could you tell us a little bit about your background? Literally from medical school to where you are now. What has been that background, that journey?
Yeah, so actually already since I was 4 or 5 years old, I wanted to become a medical doctor, not because it was something special, but probably just because my father was a medical doctor. Then while I was in medical school, I realized that for me, the most interesting organ by far was the brain. So then I had basically 3 options: neurology, psychiatry, and neurosurgery. The problem was in neurology, they only had vitamin B for peripheral disorders, aspirin for central disorders, so that was a little bit boring. My psychiatric insights were close to zero, and I loved to get quick results, so that's how I ended up in neurosurgery. Now, once I got my training finished, I looked at neurosurgery from 2 ways. One is the fun of the manual approach, and that's why my clinical work was skull-based surgery, which was technically demanding, but not intellectually very fulfilling. And so, as a compensation, my research then focused on the neuromodulation approach, which at that time was not very technically demanding, but intellectually enriching, because we basically had no clue what we were doing, and so a lot of progress could still be made. And so I ended up in neuromodulation, not via pain, but via tinnitus research, as my interest was in trying to understand the brain from what I thought was a simple pathology like tinnitus.
Although we now realize it's not quite that simple at all. Yeah. So you are the inventor of burst DR. Tell us, how did that come about?
Actually, it was not a real scientific discovery. So discovery means that you observe something new. And I was reading about 2 firing patterns in the brain in the basic science literature about tonic firing and burst firing. And then I happened to be in the Sagrada Familia, a famous cathedral in Barcelona created by the architect Gaudi. And at that time, there was a sign in the cathedral that said that the architect of the future should build by mimicking nature, because that will result in longer lasting, stronger, and more efficacious buildings. While I was reading that, I said, why don't we do the same for neuromodulation? Why don't we just mimic nature? And as I happened to be reading about tonic firing and burst firing, then I said, why don't we then just mimic burst stimulation? This, of course, forced me to think, what's the difference? Why would we have 2 kind of languages in the brain? And so then I started reading widely the work of Rodolfo Linas, the work of Sherman, ending up with the concept that they proposed, that tonic firing is just the content of the information that you transmit, and that a burst is nothing else than a signal of salience, a signal that says this is important. So when we're talking now, somebody else calls your name, that might be very relevant. Something in your brain has to tell that, and that's the burst. So considering that in general, we don't feel things that are consciously that are not of relevance, like our clothes, because there's no benefit of us constantly feeling our clothes, then pain should, in theory, also not continue to exist, because after a while, if the signal has had its function, after healing it should disappear, so there has to be a paradoxical salience attached to the pain, or the tinnitus, or the depression, whatever. And then I thought that we might have to modulate it with this burst firing pattern, or mimicking it. And then We tested it first in tinnitus because of a very practical problem that we ran into. So we were implanting electrodes on the auditory cortex for tinnitus, and it seemed to work pretty well for people with a pure tone. We're hearing a peep or a whistle, whereas for those who had more like a noisy multi-frequency component, it didn't do anything. And so then you think practically, how can I solve this problem? Or should I just stick to the pure tones? And again, you go back to the literature, trying to figure out the differences, and it appears that there were actually two pathways in the brain for sound transmission, one which was firing tonic, one which was firing in burst. The burst one just tells you there is something changing in the auditory environment, and this is non-topographic. It's non-tonotopic because it has to pick up any change. And the content is then transmitted via what we call the lemniscal system, and the same exists in the somatosensory system and the visual system. It's universal. And so because burst overrides tonic activity, but tonic activity doesn't override noise, and that's all. If the hyperactivity of this noise-like sound is related to increased bursting, then it makes sense that we cannot override it with tonic. So we have to use the same firing pattern, which is burst, so we have to develop burst stimulation. That's how it came along.
So what I'm hearing is that it started with you asking a question. It didn't start with you having the answer. It started with you asking a question.
Yes, and that's correct. And I think this is really essential, and this is why I still do clinics, because the questions that we have during the clinics are the ones that force us to be creative, to find a solution for those people who are not benefiting for whatever we do.
Which brings me to asking about inventing. You know, I'm very interested in the concept of the process of inventing. How do you think one should position one's mind in order to be creative? Because a lot of us who run a busy clinical practice, we sometimes feel submerged in the work. How do we find a pathway to be creative?
I think, first of all, creativity requires curiosity. You have to be curious. You have to want to try and understand, recognize patterns. The problem is that our brain, the way I look at brain functioning, is a Bayesian brain. Now, what a Bayesian brain does is it constantly makes not one, but multiple predictions about how to solve a problem. So you will try and solve a problem, and if you don't reach the goal, in parallel, you compute the alternatives, then you use an alternative. The problem, however, is that when people are extremely busy with a busy practice, they don't use this Bayesian model where everything that you do is then based on the model in your head of me in the world. Now, if you get stressed, you switch from this model-based approach to what's called a model-free approach, and Carl Friston calls it belief-free, which means you use habits or practical. The problem is that's non-creative. It's just what seemed to work the last time I was in this situation.
Yeah, heuristic, quick cut to deal with the situation.
Yes, just quick, very fast, very efficient, but you don't learn anything. So this is where I think if you want to be creative, you have to build in time of being non-efficient work-wise, or you have to reduce your stress levels. I mean, you can take beta blockers, you can take alpha blockers, whatever you want. You can use some oxytocin for social, but from a practical point of view, what you need is to get out of this stress-induced model-free approach and go back to the Bayesian model-based approach, and only then can your brain be creative and use multiple different predictions, and then how fast you can switch between the two probably determines how creative you are. So I think there is a practicality of how our brains, and probably the people who can quickly switch are more creative than if you really keep on thinking the data might not be good, I'll stick to the model. Or you can do the opposite, say the data, I have to adjust my model. And that's where you have to be flexible and creative.
So it was probably no accident that Isaac Newton was sitting under an apple tree, having time to think.
Yes, and some people also claim that it's related to sleep. And from a Bayesian brain perspective, what we do during sleep is during deep sleep, we store whatever occurred during the day. So we put it, we store it in our cortex, but then the problem is you can only store the exact situation. Now, we then have a second later at night, we have REM sleep, where we have most dreams. And ultimately, the function of REM sleep is to then use whatever we've learned during the day and manipulate it so it becomes more generalizable. Which also means that you have to look at what you encounter during the day from multiple different angles. And this is where creativity might also be involved. For example, Kikuchi was a chemist who was dreaming that there was a snake who was eating its own tail, and that's how we came up with the benzene ring. Yeah. So the flexibility or the integration in your model of the world has to happen enter during deep sleep, but be fully developed in REM sleep, and that's why probably sleep is also important. And furthermore, if you don't sleep enough, you go back to the stress mode where you don't use a model-based approach, but a model-free approach that is just very practical, very solution-oriented, but based on what is stored in memory.
And obviously that's about creating the substrate for being creative, but then you actually have to have the content. And if it was obvious and in front of us, we'd all be inventing left, right and centre. So I often see that people who are successful at this actually are often, the old word used to be polymath, but it would read widely, would read for reading's sake. Do you think that's important to actually just explore the world and learn things that might be directly in your narrow focus? Can it be useful later on to make jumps?
Yes, certainly, because, for example, people like William James, the father of psychology, he already said that actually creativity is combining two different entities that we know in a new way. So it's not that all of a sudden there is like a flashbulb thing that says something very new that nobody has ever thought of. No, it's often a combination of what people already know. And this is how Henry Ford started with building his cars, because he went to a meat factory where he saw that people were doing one thing. The meat was hung, and then when it came, one person would make a cut, and then the next person would make another cut, and he thought, okay, this is how I will make my cars. But then, of course, a second problem was, who do you sell it to? So he doubled the salary of all his employees so that they could afford their own car, basically already marketing that it was a car, that a car was not just for the few wealthy. So, which means that if you have a product, the product to becoming successful, that's why you need innovation. So if you think discovery is seeing something new, or the observation of something new, the inventor is not just observing, is creating something new. So in my case, the observation, the discovery was, oh, there is burst firing. The invention was, okay, we can create, we can build it, and then the innovation is done not through us, but through business. So discovery, you could say scientists and artists. The inventor is then more the technology, the engineering component of it, and then the third is the business component. But in order to be successful, that does not depend on you alone, because that depends on, for example, the company strategy, whether your idea fits in the strategy. And I think a lot of good ideas actually never become successful. So the innovator in Apple, there was already MP3 players, the Walkman already exists. There was already MP3, there was already online music stores, but what he did is he combined it in a very easy way and outcompeted everybody else. So the innovation part is actually the business component, how to transform a creative idea into a commercial product, and that is something that we cannot do ourselves. We need business, we need interaction with companies for that.
Yeah, I've sometimes said to family and friends, I've never had an original idea in my life, but I am good at stealing two ideas and joining them together.
That's creative. That's what creativity is all about.
That's right. What do you think are mechanisms of fleshing out an idea. You have an idea, but you may not know really how it can be applied or where will it be most useful. It's a bit like a tiny idea on a boat, but it doesn't know where to go in the ocean. How do you then sort of find the direction that this idea ought to go in?
Even if you don't have the idea yourself, often when you communicate about these ideas, other people might tell you. For example, with bursts, I was interested in developing it for tinnitus on the auditory cortex. And then Tim van Kamp, who was an employee of a distributor, said, "Do you think it would work for pain?" So I said, being a brain guy, yes, we can try it on the somatosensory cortex. So we wrote an IRB, we tested it on the somatosensory cortex, and it seemed to work as well. And then he basically said, "What do you think about the spinal cord?" I said, "I don't know. But there's only one way of testing it. We cannot test it non-invasively." So we wrote an IRB to do it on the spinal cord, and then I had never done spinal cord stimulation in my whole life, so I didn't even know what to expect. I was completely naive to whatever to expect. And then, so basically, going from tinnitus in the auditory cortex to somewhere else, the idea was somebody else who kind of pushed me in doing it. So because if you become too focused, if you say, "I've got this idea and I want to sell it to a company," and the company you will be very frustrated, because if you look at commercialization, only 1 in 3,000 raw ideas make it ever to the market. And only 3% of all ideas actually break even with the investment of it. So for a company, it's very difficult to know if they have 3,000 ideas, which one to follow. So that's why they tend to say, if it fits in our strategic planning, let's adopt it. If not, no, then they might not adopt, even though it could have been a way bigger success, because nobody can really predict which idea is really going to make a huge difference. So you have to have the right idea at the right time and being in the right place. Yeah. So a lot of luck is involved in it.
How do you start from, say you've now got your well-developed theory, how do you start to then roll it out into practice? What are the things that you should think of as you want to do that?
So the way I think it works is you first test an idea, if you can, for example, new waveform, non-invasively, like we do it transcranially, we see, and then every single case you do, you have to learn from in the beginning, because the idea is still vague, and then you can basically what you do is the model in your head of what you're doing becomes more and more refined, but it becomes refined because of prediction errors. Yes. Things that do not exactly occur the way you expect with your model. So the model progressively refines. And then when you think, "No, I've got this idea and it seems to work," that's the moment when you ask your friends, "Would you mind to verify this for me so that it doesn't become a self-fulfilling prophecy?" And be open that they might not find the same thing, that it was a self-fulfilling prophecy. So the first step, I think, is be your own biggest critic and refine the model by failure, which is what Churchill nicely said, is that success is stumbling from failure to failure with no loss of enthusiasm. So you basically need to refine that model, and then you have to verify it, and verify it by people others than yourself.
Which brings me to the point of, I think you have an invention, you're sometimes afraid to let it go, or whether that's for fear it gets taken over or for fear it gets laughed at. Should you bring in others early as confidants? What's the process by which you share this knowledge with others?
So initially, I do think that it's very good to share your ideas at a very early stage with people you trust. And not just trust as friends or as family, but also you trust intellectually, and who you know will be very honest and might say, "Look, I don't think it works," or "If you're correct, then this and this could happen." So you already it helps you also to refine your concept. Now, if you want to commercialize it, you first have to protect your idea. If you're not interested in the commercialization, then you can stay in the ivory academic tower and say, okay, that's it. But if you want to commercialize it, then you have to first protect it, I think, and from the very beginning, involve people you trust intellectually, and you trust also that they will not try and take away the idea and develop it themselves. Now, the thing is, if you've got only one idea, that's a problem. But if you've got multiple ideas, and you say, I will never be able to develop all the ideas, so I'm happy if somebody else wants to develop one of them. But yes, very early, involve other people.
And again, I guess that's to prevent going down a blind alley to be tilting at windmills like Don Quixote.
Yeah, no, and that's correct. And ultimately, people who are creative recognize patterns that other people don't recognize. Like the saying of Arthur Schopenhauer, who said, talent can hit a target that nobody else can. A genius can see a target, can hit a target nobody even sees. So the creative and creativity and being a genius is, of course, still different. But I think what he wanted to say is that when you see something, when you recognize a pattern that nobody else sees, then that can become a hit if it works. The problem with that is that pattern recognition is what our brain does, but it's very sensitive to influences like dopaminergic influences, stress influences, and it follows an invert U curve, which means that some mental disorders are associated with heightened creativity. For example, if you're in a hypomanic phase in bipolar disorder, if you're not in full-blown schizophrenia, but basically all hyperdopaminergic pathologies increase patterns. Now, the interesting thing is that when you recognize a pattern, in the words of Schopenhauer, then that could be a very good new idea. Now, what's very interesting is that there's something which is called the Nobel disease, where a lot of people who saw patterns that nobody else saw, and that's why they got the Nobel Prize, actually afterwards get and develop the most crazy ideas you can imagine. And that's probably because they just keep on generating patterns, but it's not because you recognize the pattern that the pattern is there in the outside world. Yeah. And you might, like in conspiracy theories, you might recognize patterns that clearly don't exist. And this is where involving other people that you trust early on might help you from going down the alley where the pattern that you see is clearly not there.
Can I ask you, if I may, did you ever feel discouraged in your own personal journey of trying to bring the concept or the theory to commercialization?
It might sound strange, but in reality, no, because my motto in life is, in Latin, it's cupio multo, expecto nihil, which means I desire a lot, but expect nothing. This is a protective concept where you can desire incredible things, but if you don't expect them to happen, then that's fine.
Yeah, everything's a bonus.
Anything is a bonus. Now, a good idea needs to be there on the right time. Yeah. If it's not on the right time. And so it's the same now with some other ideas I have for stimulation patterns, but the big companies are not interested because they are completely risk averse. So ultimately, if I would like to develop it and have to follow a similar strategy as before, start with a startup, if the startup seems to be successful, then one of the big companies will buy it, but they will not invest themselves in something that is too new. So companies are interested in innovation, which means commercializing things, but not in really inventing.
Incrementalism, I call it.
Yeah, no, that's correct. Yeah. So, and this can be frustrating, but if you know that's the way the market works, then you have to either say, not interested, or you go the startup way.
So different people think in different manners, they have different brains. Some people are visual thinkers, other people are abstract thinkers, other people are sort of workshop tinkerer, physical thinkers. Do you think it's useful to know your own style? Is that helpful to almost neuroanalyze yourself to better have an ability to develop things? Or do you just have your style and you just run with it?
It is important because I remember when I was in my first year of medical school, there was a guy who I met, and he was clearly brilliant. I mean, when you were talking to him, and you could see that. I mean, his points for physics and for mathematics and statistics were always 19 out of 20. I was way, way lower. And then I told him, I said, I don't think you're in the right direction, because medicine is going to be too dirty for you. It's not mathematical, not physical enough. And he says, yeah, but I still want to do it. And so you saw that when the basic sciences were finished, his points dropped. And actually they became like mine. And that's very interesting, because the person had clearly not chosen a study that was fitting or in keeping with his talent. And to such an extent that actually even in his research, he was not as successful as he could have been. So I do think it's important that you at least know your strengths and especially your weaknesses. Like, if I was talking with a French mathematically gifted psychologist about tinnitus and about implants, and he said, that's interesting. And I said, just wait a second. And he took a notebook and he started scribbling down all mathematical formulas. And I thought, he's just autistic, let him do. And I said, what are you doing actually? He says, I'm just trying to figure out what you told me is correct or not. So he first had to translate my words, which were visual, how I would see this thing, into mathematical formulas for him to understand really what I was saying. And at the end of 5 minutes, he said, yeah, I think you might be right. And it was a paper full of mathematical formulas, which I couldn't even conceive that you can think like that, because I think in a visual way, but for him, it clearly works very well to think in a mathematical way. As long as you optimize your way of thinking and do not, for whatever reason, think like, I could say, I would love to be like the guy and be able to think mathematically. It will never be possible to do it. So you have to adjust your goals to what you're capable of. And that's where insight, I think, is very important. As a young neurosurgeon, my goal was to become the best skull-based surgeon in the world. So I went to see all the famous skull-based surgeons, and then I end up in Pittsburgh and I watched Fukushima operate. And after 2 hours, I realized this is a level of conceptual insight in the anatomy and technical skill that I will never have. Even if I work 1,000 years, I will never be as good as he is. Which of course is frustrating, because there goes your goal, and then you think, okay, then I have to just switch goals. I have to find another goal that I can go for. And I said, okay, I'll continue doing skull-based surgery because I love it, but my goal will not be to be the best. The guy was like a Mozart, but you only have a Mozart once every 100 years, so you have to accept, I will never be that good. And then you change goals, which is, I think, also important, that if you keep on going in the same direction and you realize it's not going to lead anywhere, just take another goal.
So, there aren't sort of inventors clubs where you can go along and get tips, and I don't think there's a book in the series, Inventing for Dummies. So for somebody who has nothing, doesn't have an idea yet, but want to go on this pathway, how would you suggest that they start to learn about what they're going to need to know?
I think ask the right questions, which in our profession is easy. I mean,
there's no shortage of questions.
Yeah, if you look at where we are with neuromodulation currently, we still have to go through a lot of improvement. So ask the question is, what interests me really? Am I interested in the peripheral nervous system, the DRG, the spinal cord, the brain? And go for what you love, not for what you think might bring in most money on beforehand. Because when you go for what you love, you can spend a huge amount of energy that is helping you to really try and solve the problems that you ask. So the first thing is ask questions that you're interested in. And then of course you do need luck that at that moment, or 5 or 10 years later, what you were working on becomes beneficial for a company or for society and that. So don't start, I want to develop something that will be commercially available in 10 years. And of course, with my life philosophy, it's easy. If you say, I want a lot, I desire a lot, but I don't expect anything, then there is no goal, there's no stress that it has to become successful. And if it is, then that's nice, but you cannot. So the first thing is be curious, ask the right questions, and be lucky. Now, how can you be lucky? You can only be lucky if you do a lot. Like, I don't play the lottery, so I can't win it. So if you don't constantly persevere or constantly work on something, then the chances of being lucky are a lot less. Yeah. And this is what Ernest Hemingway nicely said in one of his quotes, is that for very long now I've been writing as good as I can, but sometimes I'm lucky, and then I write even better than I can. Which means that at a certain moment, if you're playing with it, with an idea, and you don't grasp the whole thing, then you might all of a sudden get this kind of aha-erlebnis where all the pieces of the puzzle come together, and you can call it luck or insight, whichever way, and then you can try, okay, now I understand the whole concept, now it's mature for trying to develop into a product.
So actually just practicing the process is important, just to get the brain circuitry working for you for the point at which you might be successful down the line. That actually practicing this concept of pursuing questions and then how would the question be answered has intrinsic value in and of itself.
Yes, because it has been called the 10,000 hour rule, which means that, and ultimately the 10,000 hour rule is nothing more than what we discussed earlier on. It's building a model in your brain about me and the world, or the product in the world, and you need lots of hours to look at it from every single angle. So furthermore, if the model has been repeated, it becomes a habit. That's very interesting, and there is a beautiful story about that, where there is a radar specialist who on an American aircraft carrier, and he's just new on the ship, and on the second day he sees two things coming towards the aircraft carrier, and then he has to decide whether it is two of our airplanes that left and are just coming back because they happen to be in two, or it could be two missiles. And by just looking at it, and then he decided to take them out of the air. Could have been two pilots from the own aircraft carrier. So then the question is, then they asked him, why did you give the order to take them down? And he said, I have no clue. There was just something that did not fit. That's the pattern that he recognized after 10,000 hours of, and the difference was that normally if airplanes come back, the radar would do one swipe for them to go from point A to point B. Here, from going point A to point B, it was already like half a swipe. So something wasn't fit, but he didn't realize what. And that's where the 10,000 hours come in, is that you have a model that you can apply even if you don't understand it very well. And this is where, at that moment, you're ready for building a product, because in your mind, you will know its weaknesses, its strengths, its potential, and then ultimately you have to convince other people why it's a good idea, but the need has to be there.
Yeah, underpins everything. Can I ask cheekily, what's in the future for Dirk De Ridder?
I'm more and more thinking in a Bayesian way. I haven't figured out yet how I can translate that into treatments. I have some ideas. I'm still interested in neuromodulation design, so still interested in different kinds of noise stimulations. So basically, figuring out how we can best communicate to the brain in a language that the brain understands, or the spinal cord. But the second thing is changing the way we address the brain by going from single target approaches to multiple target approaches. So I've given some talks about war on pain, war on tinnitus, war on mental disorders. And what I mean by war is we have to go not only from single target to multiple targets, because our brain are ultimately networks that have as emergent property a certain symptom, which could be pain, which could be depression. And if you go from one target, you have to be extremely lucky that you can break the whole pathological network. So we have to go to network approaches, but this requires new technology and also a new way of thinking about how do we strengthen connections. I mean, breaking connections is easy. As neurosurgeons, we did that in the 40s, just you cut. Yeah. So hyperconnectivity, and what's very interesting, all pathologies that are benefiting or can benefit from cutting are always associated with hyperconnectivity in the area where, like in the anterior limb or the internal capsule, etc. Now, going to network science, what we there want to do is we want to build new networks, not break them. So that's fundamentally different from what we're currently doing. But then you need the other languages. And so for me, the most important languages are infraslow, noise, and burst, and use them in a correct way. But we also have to think of networks that are correlated and anti-correlated. So we're testing all of that now with transcranial stimulation designs. And then the future and the longer distance is going to be what you could conceive of as reconditioning or learning, where you pair a certain stimulus with a reward or a disreward. Let's say you have an alcohol addiction, then you pair images of non-alcoholic drinks with a reward, a stimulus in the accumbens, for example, or you pair it to a disreward in the habenula, but then you link that to the alcoholic drink. But you could do that for high-calorie food, low-calorie food, you can do that for everything. So going from single target to networks, and then to learning networks. And this requires new technology, and the luck that we have now is that the new technology is there because we can recognize all these patterns, if you've got data enough, by collaborating with people that know artificial intelligence very good. I don't have to understand AI, I just have to understand the concepts and then discuss with the people who are strong in recognizing these or in showing the new structures that will then help us go to a more physiological way where we do not only block activity, but where we can create new activity and teach the brain something. So that's, I think, where in the future we have to go.
Dirk, it's been fascinating as always. I've learned a lot. Thank you so much.
You're very welcome.